Welcome back, cosmic coders, to Coded Universe. Today we're plunging into the heart of inheritance in programming. Picture it as a mighty tree with roots deep in real-world scenarios. Get ready to simplify the complex without writing a single line of code. In the realm of inheritance, our story begins with the base class, much like the sturdy trunk of a tree. This is where it all starts, the point of origin, the genesis. Just as the trunk gives rise to branches, leaves, and fruits, the base class is the seed from which other classes grow. It's the blueprint, the master plan, the DNA of your program. Imagine the base class as an entity that encapsulates the fundamental characteristics of an object. Let's say, for instance, we're talking about a vehicle class. This could include attributes like speed, color, and size, along with methods for actions like move and stop. These are the core traits that all vehicles share, making vehicle a perfect base class. Now, why is this important? Well, the beauty of a base class is in its simplicity and reusability. It's like having a recipe that you can then tweak to create a variety of dishes. Once you've defined a base class, you can reuse it everywhere in your code. This not only saves time but also makes your code more organized, efficient, and easier to maintain. Moreover, a base class promotes consistency. Because every derived class inherits from it, you're ensuring that certain standards are met across your program. Think of it as the grammar rules that give structure to a language. Without them, communication would be chaotic. Similarly, without a base class, your code might become a jumbled mess of inconsistent objects. In essence, the base class is the heart of inheritance. It's the anchor, grounding your code and providing a solid base from which you can expand. It sets the stage for the more complex functionality that will be added by the derived classes. So, just as the sturdy trunk forms the base of a tree, supporting and nourishing its branches, the base class forms the backbone of your program, defining the core attributes and methods from which all other classes grow. This foundational element bears the core attributes from which everything else originates, analogous to the shared features of your grandparents that you see within your family. As we branch out from the trunk, we encounter the derived classes. Picture this, a tree, its branches reaching out into the sky, each one a testament to the strength of the trunk from which they grow. These branches are the derived classes, extensions of the base class or trunk, if you will. They carry the essence of the base class, but they also have their own unique features, the same way each branch of a tree has its own leaves and fruits. Consider the case of a base class named vehicle. Now let's say we have derived classes like car, bike, and truck. These derived classes inherit the fundamental attributes of the vehicle class, like speed or color, but they also have their own unique properties. A car might have the number of doors as a unique attribute, a bike might have the type of handlebars, and a truck might have payload capacity. These unique attributes are what make each derived class special. They define the characteristics that set them apart from the base class and from each other, much like how you might have inherited your grandfather's nose. But your talent for painting is all your own. These offshoots, much like the branches of a tree, carry forward the legacy of the base class, while also sprouting their own distinctive qualities, just as you might inherit your parents' eyes, but possess your unique talents. Observe how the branches extend, adopting the tree's inherent strength and yet flaunting their unique leaves or fruits. Just as these branches, the derived classes in our programming world, reach out to embrace the characteristics of their origin, the base class, while also showcasing their own unique attributes. Imagine a base class called Animal. This class may define core attributes such as the ability to breathe, eat, and move. Now consider two derived classes, Bird and Fish. Both inherit the basic functions of the Animal class, but each also introduces its own unique functions. For instance, the Bird class may introduce a fly function, while the Fish class might add a swim function. In the same vein, your family tree's branches, your aunts, uncles, and cousins all extend from the same trunk, your grandparents. They all share common features like the family nose or the knack for storytelling, yet each branch has its own unique attributes like your aunt's infectious laugh or your cousin's talent for painting. This is the magic of inheritance in action, where from a single fundamental source, a myriad of unique, nuanced offshoots can spring forth. It's about taking the core, the essential, and building upon it, enhancing it, making it both universally applicable and distinctly individual. Inheritance in programming works to streamline our code, to reduce redundancy, and to promote code reusability. It's a powerful tool that, when used wisely, can make our coding lives significantly more efficient, and our code much cleaner. This seamless transition from the base class to the derived classes mirrors the natural flow of traits within a family, streamlining complexity into simplicity. Inheritance in its essence is a grand dance of continuity and innovation, a testament to the beauty of evolution and growth, be it in the natural world or in the realm of code. Thus, in the great tapestry of inheritance, each new branch enriches the tree, just as in programming, where new classes extend the functionality without uprooting the base. We've journeyed together through the forest of code, observing the robust trunk of the base class and the diverse foliage of the derived classes. We've seen how the essence of the base class, like the strength of a tree's trunk, passes on to the branches, empowering them to sprout their unique leaves and fruits. Just as a tree's branches bear the legacy of the trunk, yet also bear unique fruits, so do derived classes in programming inherit attributes from the base class while adding their unique functionalities. It's this amalgamation of inheritance and innovation that allows for efficient and effective code. In the realm of programming, understanding inheritance is not just a luxury, it's a necessity. It enables us to create more complex systems while keeping our code clean, organized, and easy to maintain. It's the secret sauce that simplifies the complex, the key that unlocks the door to a more dynamic programming experience. So, as we conclude our journey today, remember that the power of inheritance is not just in the understanding of its concept, but in the application of this understanding to your coding adventures. It's an eloquent symphony of continuity and innovation, playing out in nature and in code. Thank you for exploring the wonders of inheritance with us. If this journey sparked a light in the cosmos of your understanding, don't hesitate to like, share, and subscribe. Until our next cosmic voyage, keep unraveling the universe of code.